law. Alright, this is the first video in the new chapter of electric and magnetic fields. First topic of this chapter is electric fields, and this video will cover Coulomb's law. In the 6th century, a philosopher or a scientist of the time found that when he rubbed amber with a cloth, it attracted small particles. Now, they didn't know what this force was at the time, but they named it electric force after the amber. Now, a long time later, in the 17th century, scientists observed both the attraction and repulsion of small particles due to the charges. Benjamin Franklin introduced the terms of positive and negative to describe these. Now, when we're talking about materials, positive charges occur when you have the absence of electrons, and negative charges occur when there's an excess of electrons. Later on in topic 3, in the light and atoms topic, we will discuss subatomic particles and fundamental particles that also have charge. Now, when we have two particles that are charged in the vicinity of each other, there's a force that is experienced by both these charges. The force is repulsive if both the charges are the same, and attractive if both the charges are different. Coulomb's law states that the force experienced by both the charges is directly proportional to the magnitude of the charges and inversely proportional to the square of the distance between them. So what this means is if the charge is a bigger charge, the force is going to be bigger. Also, if the distance between the two particles is greater, then the force acting on the particles is going to be less. The charge of the particles is denoted by a lowercase q. The distance between them is denoted by the r. And this term here, when we're talking about charges being in a vacuum, we're going to use it as a constant with the value of 9 times 10 to the 9 Newton meters squared per Coulomb squared. The force calculated by using Coulomb's law is actually applied to both particles. Both particles experience the force. So you can see in the diagram here, when both charges are the same, the force is repulsive, meaning that the arrows here are pointing in opposite directions, and the magnitude of the arrows here and here is the same. And when the charges are opposite, it's an attractive force, and the arrows are the same length here. What are the particles within an atom that have charge? Find the value of these on the formula sheet.